Alright, if I want to derive this is 2x to the third, that's not a cube root, times the square root of sine x. So what you see here is you would see a product rule with a quotient involved. First thing it looks like I did here is I pulled the 2 out altogether, and then I rewrote the square root as a 1/2, and I put the 1/2 outside. Then what you see here inside, I think I did product rule. Derivative of x to the third, leave this, leave x to the third, chain rule this. Remember, don't forget when you do a chain rule, don't forget to derive sine to get the cosine right there. Once I got all this, it looks like the next step from here, it looks like this stayed, but I multiplied top and bottom by 2 sine 1/2 power, because over here when I simplified this side, I had a 2, this negative power drops to the bottom, I had sine 1/2 power. So in order to combine these two, I needed to do top and bottom here by this thing, by this, top and bottom, so that I could get the common denominators. Now these both have the same, both pieces have the same denominator, brings them together. The top then, when this sine x to the 1/2, sine x to the 1/2 becomes simple sine x. 2 times 3 becomes a 6. This just stays because that didn't change. Then the 2's cancel. And from here to here, it looks like I noticed I had an x squared in both, that I could pull out an x squared. And this had nothing left. So this looks like the answer. And we change the 1/2 power back to a square root. You could leave a 1/2 depending on the multiple choice test question type. So, product rule with a chain. Here, where are the horizontal tangent lines? Horizontal tangent lines are where the derivative equals 0. So this is a regular equation, so we derive this. So to derive this, it's a quotient rule. So derive the top, leave the bottom, minus, leave the top, derive the bottom. Don't forget about that 3. A lot of people, when they derive, they bring the 4 out front, leave this, drop 1 power. Don't forget to derive the inside. We square the bottom, which this becomes an 8th power, so right here. Here it looks like I didn't want to distribute this 4 times. That'd be bad. So it looks like what I did is I just left this. This I combined. It looks like I, for this one, actually, you know what I did? For this one, it looks like I pulled a GCF of 3x minus 1 to the third. See, this is a 4th power, this is a 3rd power, so I pulled a 3rd power out of both. Left the 8x in front. Okay. Actually, no, I pulled an 8x out of both. 8x out of this one, 8x out of this one. I pulled a 3x minus 1 to the third out of both of these. When I did that, what's left for the first one is just 3x minus 1. For the second one, you're left with just negative 6x once you pull the 8x out. Because what happens, it's kind of hard to see, but if you did 4 times 4 is 16, so if I pull an 8 out of that, it leaves me a 2. 2 times 3 is 6. You pull an x out of x squared, leaves you an x. That was kind of a lot of work. Jump from here to here is a big jump. Anyways, and the second one, we took out 3x minus 1, all of it. So basically, all of this becomes simply negative 6x, or 6x with the minus. And then it looks like once these two GCFs are out, then these 3rd power cancels with the 8th power, leaving a 5th power. This combines to give you negative 3x minus 1. And then from here, you might think you can cancel, but that's a negative, so you can't cancel. It looks very much like it could. And then to know where it has a horizontal tangent line, what you do is you set the top equal to 0. So when you set the top equal to 0, you get 0. When you set this piece equal to 0, you get negative 1/3. So at these two spots, you will have a horizontal tangent line when x are these two values, because when you set the top of the derivative equal to 0, that's where horizontal tangent lines will appear.